in the 20 teens, there is advanced manufacturing that started happening all the way up to being able to make full large aircraft in India. And that's something that only the aerospace majors know about it. Even the lesser known aerospace guys will not have seen that happen. What has happened in this decade is the advent of these aerospace startups, which are making rockets, satellites, planes, engines, and so on. So what will happen in the next decade is that these startups will actually become large companies to begin with, and eventually MNCs as well.
Hello and welcome to another episode of Speciale Focus, brought to you by Speciale Invest, a leading early-stage deep tech VC firm. I'm Hariharakli, an independent journalist in Bengaluru, and your host today. Our guest in this episode is Professor Satya Chakravarthy, a professor of aerospace engineering at the Indian Institute of Technology Madras in Chennai. Professor Satya, as he is popularly known, is the founder and technical lead at the ePlane company, a startup which is taking India into the world of electric vertical takeoff and landing air taxis, medical ambulances, and logistics. And this venture is going to be the focus of our conversation today. Apart from ePlane, Professor Satya is steeped in the development of deep tech startups incubated at IIT Madras. He is a director or advisor at multiple ventures, including Agnikul Cosmos, a space launch vehicle company, Aerostrovilos, a startup aiming to produce fuel-agnostic micro-gas turbines, GalaxEye, a startup that aims to make Earth observation satellites with multi-sensor fusion and edge computing in space, and NewTrace, which aims to make green hydrogen at an affordable cost soon. Professor Satya also heads the National Center for Combustion Research and Development, NCCRD, at IIT Madras, the largest of its kind, built with $30 million in funding over the last many years. We hope you enjoyed this conversation. Professor Satya, welcome to Speciale Focus. Thank you for doing this. And it's great to be talking to you again, sir.
Pleasure talking to you, always.
You've had several important developments at ePlane over the last 12 odd months, and so I thought it's a good time for an update. Can you start us off with a simple overview of what ePlane company is today for a general audience, and we'll go from there.
Yeah, so we started the ePlane company back in 2019 with the idea of developing eVTOLs. eVTOLs are these electric vertical takeoff and landing aircraft, which take off like a drone but fly forward like a plane and land back vertically like a drone. They don't need runways, so they can actually be deployed in most places where you can find the suitable landing spaces. And the idea here is to be able to move people across cities or within cities rather, or short distances effectively, in a much more straightforward manner without having to get stuck in traffic on the road and so on. And of course, it has other applications like air ambulances where we can carry patients very quickly to their hospitals, as well as we can also look for air cargo applications and so on. So with this, we actually purported to then realize that we need to make the most compact eVTOL in the world so that we can take off and land in tight spaces over rooftops of buildings and so on. So that required us to develop some IP that we carry with us. And where we are today is after developing quite a few subscale prototypes, starting from something that's a tabletop one which was bootstrapped first, and then to a 3-meter wingspan one that was capable of carrying 50 kgs. We've now gone to actually make the full-scale prototype, which is a pilot plus a 2-seater equivalent capacity. And we are on our way to making the first prototype in the next couple of months. And we will then go on to make the second and the third prototypes early next year. And we've already gotten the certification pathway, and we expect to go through the certification process through most of next year and complete it by the first part of 2027 and push our aircraft into market. That's basically the timeline that we are looking at.
Can you walk us through some of the important milestones? And I understand there are technical ones, including regulatory certification, some partnerships, and you also announced some funding late last year.
Yeah, so there are milestones in different verticals. On the technical side, when we developed and flew the E50 in 2023, I think we were the first ones to make a eVTOL of that class, electric vertical takeoff and landing of that class in the world, to the extent we know. Others who have actually been looking at a bit larger payloads have switched to hybrid versions and not exactly electric aircraft. That I think that's a global first. In May 2023, we got the uh, design organization approval from the DGCA, which is the India's first private company to get a DOE for building a full aircraft up to then the small aircraft category that goes on to up to a 19-seater. Subsequently, we also initiated our propeller certification in 2024. And I believe we are the first ones in this part of the world, like in the Eastern Hemisphere, to be going through a propeller certification for civilian use. That's the other, one of those first that I can say. In February 2025, we signed an MOU with a team called ICATT, which stands for International Critical Care uh, Air Ambulance Team or something.
Can you tell us a bit more about the ICAT partnership? I mean, I was reading about it, and it's a sort of an early MOU to provide close to 800 aircraft. Is that correct? And that would be $1 billion worth. This is a pretty sort of interesting strategic choice to get into the market through medical services and not necessarily through passenger taxis. You can sort of walk us through the decision-making process and the brainstorming that went into it.
Yeah, actually, our goal to pivot to an air ambulance happened in October of 2023.
Mm.
Until then, we were aggressively pursuing the idea of most compact eVTOL in the world, even smaller than multicopters that were around, without even wings. So, whereas we were competing on making an aircraft with wings that were shorter than those. And For that reason, we were actually looking at a pilot plus one passenger for the taxi application. And our conviction, which still holds true, is that most passenger travel, actually at least about some 66 to 70% or 72%. I think these numbers come from different reports of taxi travel is single passenger ride. So it doesn't make sense to have extra seats for filling them, getting some passengers to wait for the others and all that stuff. And the aircraft, as it becomes bigger, you cannot land in too many places and so on. So that was actually the conviction with which we were developing our a pilot plus one passenger aircraft. But subsequently, we realized that if I were to develop an air ambulance, that would require a pilot, a patient, and a paramedic. So that requires at least three people. Instead of the luggage that they would carry, we will, apportion that weight to all the medical equipment, the stretcher, and all those things. So we could, fit it well within what we would do for a pilot plus two passenger kind of category, and then slightly expand the wingspan to allow for that additional weight and so on. So that pivot actually happened well before where we were with the ICAT in late 2024, early 2025. Subsequent to that, we were looking at how to move a stretcher inside, and that too like a hospital stretcher, not a stretcher that's specifically meant for the air ambulance category. So today, air ambulances have a separate stretcher which fits the form factor of the aircraft, and that means that you have to actually have two people lift the patient on a makeshift stretcher from a hospital stretcher to the air ambulance and so on. So that's sort of like a hassle. Instead, we would like to see if we can push the stretcher that we see in the road ambulances into the air ambulance straight away and so on. And so we are actually working on all of those kinds of concepts when ICATT came along. And the ICATT MOU essentially allows us to collaborate with ICATT on how to formulate an air ambulance with the kind of form factor that we have, with being able to push the stretcher inside seamlessly as would happen with the road stretcher, road ambulance stretcher, and then all the critical medical equipment that are required, and so on. They are used to doing this. They have converted a bunch of different commercial aircraft into air ambulances. There are people who actually do this, get this done, and they have been working with them. So we want to co-develop this air ambulance concept with ICATT and then push it into the market over a 5-year period, starting from 2027, 2028. The idea of actually air ambulances, when we now decided that we can actually do an air ambulance, that then basically meant that the cabin had to be expanded to include a stretcher. And that also meant that I could then, in the future, have enough space in the cabin for the same footprint of the aircraft for a pilot plus 4 passengers and so on. So the aircraft all of a sudden became something that could, and then also a significant good amount of space for cargo, if you were to do a pilot plus cargo. So all of a sudden, the aircraft actually now presented itself in multiple variants that was possible the moment we embraced the air ambulance. And then we thought to ourselves that for the first prototype that's being made, it's important for us to have multiple variants of it instead of just boxing ourselves to only one use case. That pivot was actually very important. And then we have started working with ICATT. We also have a commercial thesis about it. Air ambulances will not be used as frequently as air taxis, fortunately. And therefore, we could actually price it at a higher level when compared to what an air taxi would command. And yet, we will actually be much, much cheaper when compared to present days air ambulances that use helicopters or other fixed wing aircraft for which you have to go to the airport to access it and all those things. And these are about 10 times more expensive than what insurance companies are willing to cover. So all of that stuff will actually become more affordable with air ambulances. Air ambulances will not fly long distances, and therefore this idea of actually one ambulance per district actually looks like a good idea, where you go to any remote area, pick up a patient, and come back to the district headquarters hospital, and so on. So this is the overall picture that we are thinking will spawn out in the next since 2027 to 2032 kind of time frame, and we believe that that could actually sort of revolutionize the Indian air ambulance or the ambulance scene, and we will actually position ourselves as the best in the world in that case, I would think.
As of now, which are some of the biggest markets that ICATT operates in?
ICAT actually operates out of some 8 countries around the world, India and US included, and so they do emergency evacuation, medical medical evacuation, and so on. They have a fleet of about 10 or 15 aircraft, I believe, both helicopters as well as fixed wing aircraft. And um, But it's actually quite expensive. So they want to disrupt this entire space with having electric VTOLs. So we believe that we can actually work together to get that to happen.
And in terms of the form factor, you are looking at this as a bigger version or a higher capacity version of the E200, is it?
Yes, we actually call this E200X. The reason being, we can always get this E200X to become like a pilot plus one passenger, like what we wanted. Of course, there'll be a lot of space left in the cabin, because the cabin is now large enough for even handling a what should I say, this thing, a stretcher. So, but the reason why we would do that is we can then put additional batteries for the weight saved, and those batteries will actually last for multiple trips, and the trip economics of the pilot plus one passenger could be actually very advantageous so we will have to actually see how the market um, you know emerges for demand on a single passenger ride, and we can then actually modify the E200X to just become the E200 in terms of the payload, but with the same form factor. So that's the reason why we call it the E200X when compared to E200.
Can you briefly give us a sense of the timeline now of the different variants?
Yeah, right now we are focused on the E200X, and the first variant that we are looking at is the air ambulance variant. So we expect to complete three prototypes by uh, the first half of next year, and from the first time, from the second prototype onwards, we will clock human flights. The first prototype is something that we're developing right now to test out the flight control algorithms and all those things, and we will get back to doing human flights with the PD2 starting early part of next year, and that will take us to about 1 year of flight tests from that point on, and the PD3 will join the fleet in order to cumulatively clock more hours through the second half of next year, and accelerate the process of flight tests, so that we can um, get our certification done for an air ambulance version in the first part of 2027. Now, in the second part of 2026, which is next year, we will go on to make the air taxi version, which is a pilot plus two passengers, and an air cargo version for a pilot plus 200 kgs of payload, um, with a cargo bay. These will also go through flight tests for additional certification of the cabin modification through the second the remaining part of 2027, as soon as we get our ambulance certification, so that by mid 2027 we should actually position the air taxi variant for commercialization, and later part of 2027 we can also get the air cargo variant uh, to be commercialized. So that's kind of like our time scale that we're looking at. Other variants, like if we have to make the E200X into a pilot plus four passengers, or dial back to a pilot plus one passenger and additional batteries for getting an extended range, which will then be used for many more multiple trips with single passengers, will depend on how the market commands the need.
So the first flight test of the prototype of E200 is later this year itself, is it?
Correct. The unmanned version. Yeah. The
Okay.
unmanned flights. Yeah.
Correct me if I'm wrong. In trying to do some homework for this conversation, I read that the E200X can be as much as 7 times faster than ground transport for the same point A to point B kind of connection, and roughly less than 2 times the cost of an Uber ride or a ride hailing ride, if you want to put it that way. Can you give us a sense of this?
Correct. So when we started, we knew that we were actually going to do a E200. It's only a little later that we thought about a E200X, which would carry one more passenger worth of capacity. But and then we wanted to actually develop the E50. So when we did, and then in October of 2022 is when we started aggressively discussing about certification with DGCA. We also discussed this with EASA in Europe, and prior to that, I think we also actually had international consultants to talk about either a European certification or a American certification versus an Indian certification. So all of that got settled down by early 2023 when we were on the path to get our design organization's approval with DGCA. But we also, in July of 2023, we were working with the Ministry of Civil Aviation and suggested to them that we need to have about five different working groups on different aspects of ecosystem building for uh, have the eVTOLs to take off commercially. And it's all considered to be under what's called as advanced air mobility. So in the advanced air mobility ecosystem, the plane is actually only one part of the game. We need to be able to set up vertiports. We need to be able to have charging infrastructure. We should be able to train pilots. We should have MROs that are certified to maintain and repair and overhaul the aircraft. We need to have air traffic management systems for this purpose and all of those things. So we had and we suggested that these working groups should be established. We also partnered with the World Economic Forum on developing what's called as an India ConOps document for how we will want to develop the concept of operations for eVTOLs in the country. We have worked with the Ministry of Civil Aviation and the WEF to scout for sandbox locations in Gujarat and Andhra Pradesh as of now. And we expect to participate in those sandboxes as and when that it gets set up and operationalized through 2026. So lots of these things have been done by us in the past, so that we have a sort of a roadmap to getting to the point that you talked about, which is the seven times more, far faster than ground transportation and less than twice the ride-hailing fare. So that will actually happen when we get to a certain scale of about maybe 50 aircraft that are flying in the skies in a particular neighborhood, as in a particular city. And we expect to do that through the 2027-2028 timeframe by getting into some limited series production at the capacity of about 100 to 200 aircraft per year, but ramp it up to going to about 1,000 to 2,000 aircraft per year by 2029-2030. But in the 27-28 timeframe, we should be populating, starting with about five cities with about five aircraft each, sort of level. We have to then rapidly populate with pushing 10 aircraft into certain cities first, and then similarly in other cities, but also expand the number of cities that we want to go to, and so on. So for which we are actually scouting for vertiport partners at the moment who can set up these vertiports, because the vertiport standards are out. So the working committees were set up by the DGCA. So the vertiport standards are out. The aircraft certification standards are out. The pilot training standards are out. MRO standards and this one, the air operator permit standards are on the stakeholder consulting phase. So there are all these steps that are actually happening, by which we should go to market by 2027 and expand from then on, city after city after city, one aircraft at a time that gets added on to the fleet there, and so on, and more vertiports being springing up, and so on. Yeah.
So suddenly, you all have worked towards making India one of the leading eVTOL markets, and that's really sort of quite amazing. To your mind today, what are some of the top innovations that stand out with the aircraft that you are developing?
So right from the beginning, we decided that we will actually go for what's called the lift plus cruise configuration, which has a separate set of vertical rotors and forward propellers. So it takes off like a drone vertically and lands like a drone back vertically with its own set of rotors, but we will have a separate set of forward propellers being used for forward propulsion. So you don't have to tilt any rotors and all that stuff. So the tilt rotor idea was to save on weight so that we are using the same hardware for these different operations, different phases of flight. but it is fraught with its own challenges, which is what some of the other people in the world are facing. The liftless cruise configuration is an extremely safe configuration. So, and we have a certain IP that tries to alleviate the weight problem as well, the dead weight problem as well. That we have a way by which we can utilize the vertical rotors in forward flight that aids the aircraft being very, very short in terms of its wingspan, and also to be able to fly very slowly. And the slow flight is important for us to be able to do multiple short trips in a single charge, because you don't want to be flying very fast and accelerate to that speed and then decelerate back and covering a long distance for you to be effective. Uh, if you want to be effective, you should actually be targeting low speeds for short flights. Those are all IP. Those are all some IP that we have actually clocked, filed patents across about 55 countries in the world, and in 25 jurisdictions, and got about 6 or 7 of them granted already, and it's still under examination in the remaining ones, and so on. And this lift plus cruise configuration allows us to offer about some 7 levels of safety, which is unprecedented in our view. It does allow for up to a 2 engine in operative condition in either vertical takeoff or forward flight independently. And then we can switch to the other mode of flight, which is either VTOL assisted or wing assisted. Plus, we also have, of course, things like parachutes and inflatables, and the crashworthiness and cushions for the seats and all that stuff. And of course, to start with, each of these rotors and propellers is connected to a powertrain which has dual redundancies inbuilt into each of those powertrains. So the safety standards that we are aspiring to put out into the market is unprecedented, and we want to be known for that particular aspect.
Just for us to sort of imagine the aircraft in our minds, how many rotors, how many propellers will these have? The E200X?
Yeah, so ours actually has about a total of 10 of them. If you look at Joby, there is about 6. And if you look at these are very large propellers that all of them tilt. But if you look at Archer, there are 12 of them, 6 of them tilt, and so on. So we have somewhere in between. We are about 10, which is 6 vertical and 4 forward.
And what kind of batteries and battery capacities are we talking about?
Yeah, these are typically NMC chemistry batteries, lithium ion. NMC refers to the cathode chemistry. These have about a energy density of somewhere in the 250 to 270 watt per kg kind of energy density. Yeah, these are on the high end of energy density in lithium ion category.
And with this kind of capacity, how often does the battery need to be charged for the aircraft in a 24-hour cycle?
Yeah, so we believe that we need to charge the aircraft about 2 to 3 times. And let's suppose that we have a trip of about 20 to 30 kilometers every time. We expect that we can actually do about 3 such trips before we want to have a full charge. But in practicality, what we will do is we will have partial charging happen in between trips. And these could also be in the form of fast charging and rapid charging. So it's possible for us to actually quickly top up the state of charge from some value to something higher, so that we can clock one more trip without having to wait for a full charging, and so on. So these are all sort of configurations that we will have to evolve. So one of the ways by which we're doing this is to look at what are all the demand centers in a city for eVTOLs to be what do you call, onboarded and then offboarded by people, and then where do we want to position what kind of charging infrastructure, so that we are not having too much of a downtime for charging. So charge as you go would actually be the way we will operate. In which case, you will not be able to actually answer this question precisely about how many times we would charge. We will pretty much charge a little bit every now and then, sort of thing.
And that could be typically as as low as 5 minutes, 10 minutes, 15 minutes.
Correct. So
Right.
somewhere between 5 to 20 minutes is our rapid to fast charging kind of time cycle. Yeah, slow charging will take about an hour or so. Yeah.
In terms of partnerships at ePlane, another notable one that comes to my mind is with Empire Aviation. Can you give us a sense of how you look at ePlane as a global company in the coming years?
So the thing about aviation is that it is its internationalization is restricted by the ability to get certification in different geographies. So our Empire Aviation, so whoever we are partnering with, even if they are based outside of India, will be for the India play to begin with, because India is where we expect to get the certification done. But that said, we want to see how the India certification can aid us to get certification in other geographies, and we should then rapidly start exploring how to get the other geography certifications as well, and that will then spawn multiple different markets to be explored. So Middle East is one of those. Southeast Asia is one of those. Australia, for the kind of distances that they have to travel, and Far East Asia like Korea or Japan, any of those kinds of places, and then we can get into parts of Africa and Latin America. These are all prime markets for the kind of price points at which we can operate comfortably. We can be extremely competitive even in Europe and North America, but a startup always actually tries to avoid competition. And if there is competition I think Europe was having some competition before, but now that's getting dried up. So we could also, Europe is actually also a good example of short distances, because their population may be low, but their population densities in cities is actually quite high. So that also augurs very well for us to expand into. But again, as I said, all of these will have to be done one after the other as we are going through certifications in these different geographies.
And in the Indian markets context, you've coined a term defrastructure a couple of years back, I think, wherein one can get around the need for massive investments by applying smart modular technologies and eventually achieve scale, make things accessible to a large number of people and so on, is how I understand it.
Correct.
Can you walk us through this? Give us a peek into the thinking in your mind when you were thinking about all of these things.
Well, two things led to that particular thought process. One is we were at NCCRD, which is the combustion center that I had set up in IIT Madras. We had these bunch of startups that were coming up, where we had small rockets out of small launch pads that were getting built by Agnikul, and ePlane was actually making these small aircraft that could take off and land from rooftops. We had extra fuels that actually tries to make crude oil out of municipal solid waste, and so on. So multiple such startups were coming up, and it was out of necessity that we were doing these. That we can't all of a sudden, compete with a Boeing or a SpaceX or any of those kind of big people. It requires a lot of capital, but at the same time, whatever capital that actually gets utilized for making these small products should also see markets for these small products. So it doesn't make sense for us to just do what we can do rather than what we need to do. So we found that there is a need for small rockets. There is a problem that we are solving with small rockets. There's a problem that we are solving with small satellites. There is a problem that we are solving by utilizing municipal solid waste and making crude oil out of it, in a distributed manner across the country, and so on. So all of these things were sort of independently happening out of necessity, the way they were supposed to happen. And then, on the other hand, we found that a fast emerging economy like India was always getting challenged to be able to develop public infrastructure to match the kind of let's say lifestyle that a developed economy would afford to its citizens. And I asked myself, is that the right thing to do? I mean, is that necessarily the right path to approach? Because public infrastructure requires a lot of spending, and a lot of spending means that we need to have like lots of taxes, and we also actually have to have a large tax base. Now, India could be a place with a lot of taxes, but the tax base is actually not as large. And then of course we have all the endemic problems of corruption and all those things. So when you now try to entrust things to be done in a publicly large scale manner, then there are delays and unaccountability and all those kinds of things. So it's all fraught with lots of those problems that we are very much familiar with. So if you have to break our shackles out of that, we have to think a bit differently. And things like, for example, UPI is a great example. Mobile phone is actually a great example of democratizing, telecom access to people. So these are things that actually have been happening already. Like rooftop solar is actually another example, and so on. So all put together, I think we need to now recognize that we don't need to have one particular model of development. There could be multiple other models which are more grounds up, which actually has participatory approach that people jump into and contribute and actually vitalize the economy that way too, right? So that's the whole idea of the term that I coined called infrastructure.
In practical terms, can you give us a sense of how it might work? I mean, if it's possible to illustrate it with the example of ePlane company or the deep tech ecosystem in the country, or any other examples that come to your mind.
Yeah, so look at ePlane, for example. I think it's a good example to begin with. So we'll start with existing helipads. We will start with existing open spaces for vertiports. Then we will start looking at large buildings, rooftops, parking decks, rooftops for these vertiports. And then we will get into rooftops of apartment buildings and so on. And then we can populate the pretty much the entire cityscape with a whole bunch of vertiports. And then we start flying planes from one vertiport to another. Each of these vertiports are under regulation. They are hugely regulated. They are registered. They are on the air map of the ATC and all of that stuff. Nothing is done without any authorization, right? So in that sense, India suddenly becomes much more disciplined in its mobility, which is something that we have not seen on the roads, right? So high tech kind of necessitates that kind of discipline, and so on. So and that's important for a country to grow. So once we do this, we'll also actually find that these aircraft are also getting better and better. They can carry more passengers. They can go for farther distances. So you can actually have a taxi which is worth like a family kind of going from not just within the city, but for commute, but also for leisure outside the city, for tourism, pilgrimage, and all of those things. And pretty soon thereafter, you could actually find that people can actually go from one city to another city with these air taxis. So I can take off from the rooftop of a building that I am in Chennai, and then I may be able to actually go all the way to a rooftop of my choice in Bangalore, and which essentially means that we may not really require all the big airports that we're talking about anymore. People don't have to go 2 hours ahead of time, waiting through traffic for about another 2 hours and all that stuff, and then land on the other side, pick up baggage, and then get into a taxi, do another 2 hours of travel. All of these things is actually cut out, right? We are actually, if you want to go by air from one place to the other, you go only by air from your place to another place, right? So that means that you just cut all the crap, as they say. So this is something that will essentially challenge the notion that you need to have very large airports, palatial ones with all the malls and eateries and all that stuff, guzzling a lot of electricity on air conditioning of those very high roof volumes of air. I mean, a lot of those things actually don't make sense at all, right? So we'll just cut through all of that, and then we'll simply say that people will just get on with their business, what they want to do, which is to go from one place to the other.
Hmm. Yeah, it's interesting. And this kind of a philosophy is being applied in multiple areas, right? I mean, including manufacturing, where people are trying to reimagine what factories might look like.
Correct.
They could be on demand, even mobile,
Yeah.
and so on.
3D printing, metal 3D printing does that for you now, and so on. Yeah.
Right. Um, so let's talk about that ecosystem a little bit in the ePlane context. You mentioned earlier how, on the regulatory front, a lot of things are already in place now in terms of standards in India, and other standards are in advanced consultation and so on.
Right.
But can you give us a sense of overall what does the ecosystem look like, from the talent pipeline to the supply chain of vendors and manufacturing capabilities, and of course the enabling funding and business infrastructure? What are some good things today in the ecosystem in India, and what is still work in progress?
Yeah. So, one of the things that's actually not talked about much is the talent pool that we have, and that's come pretty handy for someone like ePlane. And I knew this because I've been an aerospace professor for nearly 30 years now in India, and I have grown along with how the aerospace ecosystem has grown in India. So when I joined at IIT Madras in the late 90s, we probably had only the public sector to talk about for aerospace. But pretty soon, within about a few years, like end of the decade, end of the century, last century, and early this century, in the 2000s, that is, we had MNCs set foot to do design. And within about 10 years, in the 2000s, the first decade of the century, the growth of design and development centers for all the major aerospace companies happened in Bangalore. And and then of course it spread to Hyderabad, it spread to Chennai, and then in Pune and all that stuff, right? And maybe some places in Gurgaon and so on. So and then in fact I think you remember that Aditya Ghosh, former CEO of Indigo, now Akasa co-founder, mentioned this in one of the panel discussions about a few months back, that the triangle of Bangalore, Hyderabad, and Chennai probably has more aerospace engineers in the world than anywhere else in the world. That is and that's probably true. And so that's actually the 2000s. In the 20 teens, there is advanced manufacturing that started happening all the way up to being able to make full large aircraft in India, and that's something that the only the aerospace majors know about it. Even the lesser known aerospace guys will not have seen that happen. So why is that happening? It's obviously because there is a very good labor arbitrage, as well as a very high tech potential on the talent side. So we can deliver exactly like global aero standards from this country. What has happened in this decade is the advent of these aerospace startups, which are making rockets, satellites, planes, engines, and so on. So what will happen in the next decade is that these startups will actually become large companies to begin with, and eventually MNCs as well by themselves. And so that's when you get to the 2040s, we should actually see a lot of Indian aerospace MNCs. So this is a juggernaut that's actually kind of going decade on decade, starting from the beginning of the century to getting to where we will be in the middle of the century. And that's something that a lot of people actually don't get to see. They don't even think about it. They don't even know, right? It's kind of like the best kept secret sort of thing. And in the meantime, the ISROs and the DRDOs of the country are doing fantastic as well, right? So it's not as if like we needed the MNCs to come and sow the seeds of it and all that stuff. That was required for the scale. In fact, it was not enough scale, right? The scale comes with these startups growing and becoming big companies by themselves and so on. So all these things are actually kind of gradually scaling up. So from that point of view, I think the talent pool issue is not a big problem at all. In fact, we could say that there's an advantage that we have over there. On the ecosystem side, I think on the manufacturing side, for example, as I said, we actually make full bodies of aircraft and all that. What we have found is that on the avionics side of things, we still are probably lacking on aero grade hardware. Like civilian aero grade hardware actually has its own demands when compared to mil grade, which is military grade, and then there is space grade. So there are two or three different grades of aerospace hardware of electronics that we have to develop. Space grade electronics has been done for ISRO in ones and twos. ISRO, the reason why we need to have space startups is because ISRO wants the scaling to happen in that sector within the country. So the government organizations alone cannot actually offer that kind of scale, but they can offer the kind of capability. So capability is different from capacity. So we are looking at space grade is there, mil grade is there, but civilian aero grade is lacking, and we are now looking at how to tap into those who have been working at a smaller scale on space or mil grade to see how they can get into aero grade and scale. So getting into aero grade and scaling are two steps that we have to actually spawn in the avionics ecosystem. Otherwise, manufacturing wise, carbon fiber and other machining of things like molds and other tooling and all that stuff is actually pretty much standard. It's available within the country, not a problem at all. Right, we can do this quite quickly. The third is actually the investment ecosystem, and the investment ecosystem definitely has a lot to be desired. I would say so. Other than people like Special and very few people who are beginning to now emulate Special, we're not really seeing a lot of funding forthcoming from the conventional VCs, and that's something that we have to acknowledge in public and challenge people to pry open the purses for something that's as risky. When we are even de-risking technology, we are de-risking regulation, we are de-risking markets, and so on. Coming so long away, like what Agnikul has done or what ePlane has done over the years, what Ether had done successfully and shown, what IDAForge has done in the past, and so on. So there are now examples that are emerging that should actually wake up the VC ecosystem to embrace more of deep tech investments when compared to what they would normally do today. And it's kind of growing, but we probably want to see that grow faster.
Your relationship with Special Invest, people talk about, in the startup jargon, they talk about founder VC fit sometimes.
Yeah.
Does that make a difference, especially in the deep tech context?
Yes, it does, because it's important that the founder actually, the VC actually understands the vision of the founder, and maybe over time, as times evolve, the VC could shape the vision of the founder as well, because the vision is not a static thing, right? But we have to sort of be able to see what's the kind of firmament that we are after about over a 10-year period, and that's not so easy, right? So because deep tech takes time to mature in terms of the product, the technology, the product, the market, the regulations, all of those things. And so a VC should actually have the prescience to sense this well ahead of others. So Special actually is good at kind of jumping into something, kind of having a sense that this is going to be one of the futuristic things and stuff, but not bet too much into the future. There is a 7 to 10 year exit that they have to plan for, but they need to envision what's expected to happen because of a particular founder and his company over a 7 to 10 year period, and that's something that Special does very well, in my opinion. And that founder VC fit is actually super important. They should see what the founder is after, and of course they can shape that vision over time, and themselves get shaped, right? So Special also actually I've seen get shaped up by market forces over time, and they've done it extremely astutely, in my view. Yeah.
And I wanted to briefly ask you about Amberwings, and I think this is also a good time to ask you about it, and also tell our audience that this is another exciting area in which you have added to ePlane company, the drone unit or subsidiary within
Yeah.
ePlane. Can you give us a sense of what Amberwings is about?
I mean, to be honest with you, I think Amberwings was an inevitable pivot on the side. So the key thing is to be able to do this on the side rather than abandon your original plan and then just pivot completely. So if I have succeeded in the latter, I think I can pat myself on the back. So the point was we developed these Bing VTOLs early on in 2018, 2019 timeframe, even before we got our first seed funding. So that was something that we did with my bootstrapping. And that was primarily to showcase to investors what we are capable of doing. And in 2019, when we had these aircraft, like what we now call as Atwa 1, that's getting commercial, which got certification a couple of months back. So when we got there in 2019, we had a fork in the road. We thought that we could actually just start with a drone company and go sell drones, make money, and then go make the eVTOL. And it's interesting that in 2019, India actually had no regulations on drones, and therefore a lot of investors called that out and said that, hey, you're doing something actually that's illegal.
Uh,
So there's not going to fly anytime unless there is clarity on regulations. So on the other hand, people were actually willing to bite into the taxi story because helicopters exist, human flights across the city exists. So there are helicopter operating procedures. What we are building is a very affordable, modern version of a helicopter that's fully electric and combines things about planes that makes it safer when compared to helicopters are. So it's a kind of like a 21st century helicopter, if you will, right? And so people were able to wrap their heads around the fact that this will work. There will be regulations that come up specifically for this, but there is nothing stopping it from happening, and so on, right? Whereas people may be a little bit upset about unmanned aerial vehicles flying over their heads and dropping from the skies uncontrolled and all that stuff, which is the reason why you see that drones, except for wars, is actually a bit slow on the uptake in the civilian realm. But it'll happen. It'll happen over time. What specifically changed was the Ukraine war. So when we had these, and then when we went on to get the funding for eVTOLs in 2020, obviously we wanted to make a subscale prototype to de-risk the technology and do all our learnings in a frugal manner. So Special was aligned with that idea. But the point is, like, by 2023, when we completed that process and we flew the aircraft, that's when there was a lot of attention to drones in warfare. And that came primarily from the Ukraine war. Um, and I think the Indian army then started embracing the idea of being drones being used, and then lots of drone companies came up. The Indian government relaxed the drone rules significantly in 2021. They spawned. What they realized was that by actually using civilian drone rules, they can spawn military def tech. So the idea of def tech actually has happened only in 2024 ish. A little bit before, let's say, Ops Sindoor that happened earlier this year. But the idea of actually drones started from 2021 onwards, mid 2021 to late 2021. So in 2022, 23 time frame, there was a lot of spawning of drone companies from the civilian push that fed into the military, process. That's fueled by the Ukraine war, and followed by that the Hamas-Israeli conflict, and so on. And then the Ops Sindoor actually has kind of sealed the idea that we need to have a lot of these drones. So our idea of actually having Amberwings as a separate entity has been extremely timely. And we now can actually go the whole hog with that particular thing. We now have appointed a new CEO for it. So he's envisioning how to take Amberwings to its greater heights where it belongs, and so on. So we think that we can focus on the defense side of things with Amberwings, as well as, of course, we want to explore the civilian side of things as well for multiple different use cases for cargo and mapping and all of those things. So we're not really giving up on it, but startup always makes hay while the sun shines. So that's where we are with Amberwings.
If one looks at everything that you've done over the decades, in fact, you've achieved something quite rare in India's startup ecosystem, and definitely within deep tech, even more rare in the sense that you've made a fantastically successful transition from being a top researcher and academic to founding multiple successful startups. Correct me if I'm wrong, three of your companies have made it to the World Economic Forum
Correct.
Technology Pioneer list.
Correct. Out
Can
of
you?
out of 10 in India.
Yeah, yeah. So simply amazing. So can you, give us a sense of, how this works for you, balancing your role as an IIT Madras Don with being a serial entrepreneur. Where does the passion, the energy come from, and how do you see your sense of purpose?
I think it's about uh, doing what makes sense, right? So um, there are lots of technological needs. So first of all, most problems need not necessarily have a technological solution. That could be a business innovation, or whatever it is, right? So you don't need to necessarily always, look for a hammer and look at all problems as nails that the hammer can hit on. So that's actually one of those things that you have to prevent yourself from doing, because you're a technologist. But being a technologist, we do come from that angle, which is what are the technological problems that we can solve. And in bureaucracy there is this word called please do the needful, right? That's exactly what we want to do. Right? So we just want to be able to solve problems. So when I was a professor, we were working with ISRO, GE, DRDO, and all those people, solving parts of their problems, let's say, not the full problems, and so on. But we did things fairly extensively. So we did the combustion center was actually fairly extensive in terms of how it could, take on research on rockets and jet engines and all of those things. So when we were actually be able to do things with that much of depth, why might not we develop full-fledged products, at least in the small category of each of those, right? And that's essentially what started out. But what's important here, when I said that you do what makes sense, is you just don't do something just for the sake of it, just for being able to do it. You have to look at a market for it, and you have to have a significant market size. You must be solving a meaty problem. So you need to be solving a problem that actually affects a lot of people, and therefore there is a value multiplier to it, and so on. If you're not really after some large markets, I think you're wasting your time. In my view, right? That's one that my personal view. So that's what motivates me.
Can you extend this into thinking in terms of advice for the next generation of deep tech entrepreneurs in India, given all the uphill challenges they have to face?
No, I think it all comes from some passion, right? So if you're passionate about doing something, just go for it. India definitely has now become a huge land of opportunities in the last one generation since the advent of liberalization or whatever. Of course, still a lot more to go, but we can clearly see uh, we now have probably at a tipping point where we can clearly see as much opportunities that's available here as, let's say, what used to be called the land of opportunities that the US is. And there are people who actually are even packing the bags from the US and coming back to India to explore these opportunities now, simply because it's an emerging market. This is where the market size is large. There is a purchasing power parity that we enjoy. The purchasing power is pretty significant, with large middle class being there. So all of these things really count for something. And in which case, pursue your passion is very simple advice that I can think of.
Okay. I want to bring it back to ePlane company before we wrap up. Over the next, say, 18 months to 2 years, or even 12 months, if we were to ask you to list your top two or three priorities, what would those be?
Get the plane out. Single point agenda. Yeah, but then so when you say get the plane out, it actually can be broken down into multiple milestones. So we have to go through each of these prototypes. We have to adhere to certification. We have to shore up on the safety standards. We have to then get into like a limited series production capacity to be established, and then start producing these in some small numbers before even certification. Is when the light at the end of the tunnel is there on certification, we should actually be producing a few of these so that we will be able to put them into the market the day after we get the certification. So that's the pathway to what I just said, which is to get the plane out. All of that stuff is actually the ePlane story, and then in parallel we will have the Amberwings story evolve with multiple different military as well as civilian applications that we are scoping out in the next year.
That's it for today. You can find links to the ePlane company as well as Speciale Invest in the show notes. If you're an aspiring deep tech founder in India, do look them up. We'll be back soon with another episode of Speciale Focus. Until then, it's goodbye from me, Hariharakali. Thank you for joining us.